Welcome to question 7 of the Leaving Cert Ordinary Level Paper 1 2025. So let's get stuck in, and we have a kind of graphs interpretation. These questions can be okay, can be tricky, so we'll give a good read of it. As always, pause the video to give it a go yourself and see how you get on. So the diagram below shows the value of one share for company A in euros on the first day of each month from the 1st of January to the 1st of July. So we see here on the y-axis is the value of one share, and on the x-axis is the months. So as time progresses, the share price goes up, up, down, down, up, up. Okay, so there's a decent spread. Now part A, part 1 says use the graph to estimate the value of one share on the 1st of March. So the beginning of each month is the 1st of March. So I'm going to estimate the price there as being €7. Okay, now it's a little bit off. You can maybe make 7.1, but 7 should be within the range. Then part 2 says use the graph to identify the month during which the value of one share increased by the greatest amount. So you can see it increased from January to February by about €1. It increased from February to March by about a little over €2. It decreased then from March to April, decreased from April to May, then increased by like almost €5 in May, and then increased by €2 in June. So the share price has increased in many months, but changes the most from May to June. It goes from approximately €1 to €6. That's it. Now, part B says on the 1st of August, the value of one share was 15% lower than it was on the 1st of July. By reading from the graph and doing calculations, estimate the value of one share on the 1st of August as accurately as possible, and hence plot that point on the diagram on the previous page. So this is the diagram here. Okay. So we see here, so we're going up from the 1st of August. It goes up by 15%. So if it's €8, okay, I should have a calculation here. The value on the 1st of July was €8. It's going up by 50%, which is €1.2. So we're looking at roughly 9.2. And I'm graphed it already here, and I've kind of tried to estimate where 9.2 would be, and that's my extension. So not too bad, just lots of words, so be careful reading it. It doesn't bamboozle you in terms of what's being asked. Now, part C says, later in the year, Liam predicts the value of one share. The error in his prediction is €1.50, which is a percentage error of 16.3. Find the value of one share at this time. Give your answer correct at the nearest cent. So percentage error is given by the actual value take away the true value, or so the observed value take away the true value divided by the true value, multiplied by 100, because it's a percentage. So it's a kind of formula I struggle to remember. Okay. Now we were given that the percentage error is 16.3. Okay, so that would be in this part of the calculation. And we're told that the error is 150, which is this value up here. So the observed value take away the true value, that's the error. Okay, that's 150. So the equation starts off with like 3 unknowns. You could argue 4 unknowns. Well, we now know 2 of them, so there's only 1 unknown, so this is solvable. Okay, so I fit it in with the data I have, 16.3 on the left, 1.5 on top. What the true value is unknown to me, and that's multiplied by 100. So I need to use algebra to try and resolve that. Now, this is an equation of 1 unknown, so it is solvable. It's just a matter of going ahead and doing it. Okay. Now what I've done here is the 100 is multiplied on the right. When that moves across to the left, it'll be the opposite. It'll be divided. Okay, it'll divide into everything on the far side. So that's here. Moving on then, I'm going to move the x over. I don't know why I did the 100. I'm actually moving the x over to the right and the 100 over to the left. So I didn't actually need this step. I don't know why I put it in. That gives me an answer then, because the 16.3 is multiplied on the left. When it comes across to the right, it'll be divided, and it'll divide into everything on the right. That's a calculator job. Okay, when I put it to the calculator, I get 9.202. To the nearest cent, okay, that's 9.2, €9.20. That's it. Tricky question, because if you don't know this formula, you're going to struggle. It's worth using the number jar and just trying to throw them into a made-up formula if you're struggling. But if you can remember the formula, it could be easy peasy. Now, part D says the value of one share for company B can be modeled by the function P of M is equal to 2 times 1.29 to the power of M. So it's kind of an exponential function where P of M is the value of one share in euro, M is the time in months since the 1st of January, and then they give you this kind of range between with 0 is less than or equal to M is less than or equal to 6, and then M is the element of R. It just means M can be any number. Okay, it could be a fraction, could be a decimal, could be a whole number, could be a negative number, could be a positive number. Now, part 1 says complete the table below to show the values of P and M for the given values of M. So these are your values of M here. Give each value of P of M correct to 2 decimal places where relevant. Now, they've pre-filled with 3 answers, so I'm going to test one of them. Okay, I'm going to go to the power of 0. So that's my function. I'm putting into the power of 0, and I should get an answer of 2, and I do. So all we have to do is the same thing for each different value of M that's not already given. Now I'm putting a sample calculation because you're going to use the calculator for this. So for the February result, the M is 1. So P of 1 is equal to 2 times 1.29 to the power of 1. That gives me an answer of 2.58. And I just repeat that for April, May, June, and I'm already given July. And that's it. The same calculation. Make sure you to show a sample calculation in case you program the calculator wrong. Your answer should be consistently wrong, which doesn't have as big a penalty as if you have all the wrong answers with no work shown. In that situation, you get 0. Okay. Now, part 2 here says the graph of company A is shown again below. On the same graph, draw the graph of P of M, which is the one we just found, for 0 is less than or equal to M is less than or equal to 6. So just basically across the 6 months. And again, M can be any number. So I'm going to start off here. I did it wrong. From January to February, it goes up from 2 to 2.58, and I'm kind of estimating that. Then it goes up from 2.58 to 3.3. Then from 3.3 to 4.29. Then from 4.29 to 5.54. From 5.54 to 7.14. And lastly, from 7.14 to the answer given, which is 9.22. So a steady trend upwards. Okay. Now, if I move on then to part 3, at only one point in the time period shown, the value of one share for company A is equal to the value of one share for company B. According to the function P of M, in which month must this have occurred? Now, if you had both models, you could use simultaneous equations, but that would be a fairly long-winded because they're fairly non-standard functions. But a much easier way is to just identify that the point of intersection is where the 2 lines or the 2 functions meet. Once we can observe that, which we can, based on our graph, we can read off the answer, and they're both models are in March. So the share price becomes equal in March. Now, part E says, according to the model, the value of one share for company B reaches its highest value on the 1st of July. And from then onwards, it declines at a steady linear rate of 30 cents per month. A new function is created to model this decline, where Q of N is the value of one share n months after the time the share reaches its highest value. And they say n is an element of n, so the number of months is a natural number, so it's a positive whole number. Part of the function is shown below. I say Q of N is equal to something, take away 0.3n. Now this is kind of illustrating the 0.3, so 30 cents in euro is 0.3 euro by the number of months. We have to look back at the graphs. We're talking about the 1st of July, and we're talking about 9.22. So from then on, it's decreasing by, in a linear fashion, by 30 cents per month. Okay, so probably not that steep, probably much more gradual. That's it. And you just have to kind of get the starting price of company B in July. That's really all that was being asked here. Now, part 2 says, using your expression or otherwise, find how many months it takes for the value of one share for company B to fall below its value on the 1st of January, according to the model. Remembering again that n is an element of n. Now, the first thing we can do is identify what the price was in January. So to recognize that should get you the attempt. And then we can, this is our graph our function as we identified in part one. So this is an inequality. When is this less than 2n or less than 2? So we're looking for what value of the expression is greater than 2. So once we make that leap, and it's a fairly significant leap to make, you have to just solve the inequality. Okay, now it seems to be fairly straightforward. So I'm just copying it over here. I'm going to bring the negative 0.03 over to the left to change as positive. Bring the 2 over to the right to change as negative. All I have to do now is take those two numbers away, and I get 7.22. And then I'm going to divide both sides by 0.3. And if you ever want to get rid of something in front of a variable like an x or an n, divide by the number. They will cancel to give 1. If I do it to one side, I have to do the same thing to the far side. I end up with a value of n is less than 24.06 months. Now they say in the question that it's a natural number, so it's a positive whole number. So the closest month, once you've gone into 24 at all, it jumps to the next month, and that's 25 months. So I think that's the end of question 7. Okay, as always, if you want to copy these notes, just send an email to shanetroy@gmail.com. Like and subscribe to get access to more playlists. Best of luck.